At 9.5 feet wingtip to wingtip, the California Condor is the largest flying land bird in North America. It weighs 25 pounds. It can cover 150 miles in a single day without flapping once, riding columns of warm air up to 15,000 feet. For tens of thousands of years, it cleaned a continent. And by 1987, there were exactly zero left in the wild. Not zero in California, not zero in the western United States, zero anywhere on the planet. 27 birds sat in cages at two zoos in Southern California, and that was the entire species, every single one. The skies of North America, for the first time in at least 40,000 years, had no condor in them. Getting from 27 cage birds to what exists today required building something that had never been attempted. A life support machine stretching across 4 states and 2 countries, designed to keep a single species alive indefinitely. Not a sanctuary, not a breeding program. A system so intensive that every wild condor on Earth is caught twice a year to have poison filtered from its blood. The condor recovery is not a feel-good story about nature bouncing back. It is an engineering project, and the machine has to run forever. To understand why the system had to be this complex, you have to understand how the condor's world broke, because it didn't break the way you'd expect. The landscape itself looked fine. The mountains of Southern California were not strip-mined. The forests were not clear-cut. The rivers still ran. If you stood in the condor's remaining territory in the early 1980s and looked around, you'd see what appeared to be perfectly healthy wilderness. Thousands of acres of protected land, rugged canyons, remote cliff faces ideal for nesting. On paper, the habitat was intact, and the birds were dying anyway. The problem was invisible. It lived inside the food. Every carcass a condor ate, every deer, every feral pig, every cow that dropped dead on a ranch had a chance of containing something the bird's own body would turn into a weapon against itself: lead. Specifically, fragments of lead hunting ammunition. When a lead bullet hits an animal at high velocity, it doesn't stay in one piece. The impact shatters it into hundreds of microscopic shards that scatter through the tissue, especially the guts. Hunters routinely field dress their kills in the backcountry, leaving the organs behind, or a wounded animal crawls off and dies. Either way, the remains sit on the landscape, and condors, whose entire evolutionary purpose is to find and eat large dead things, arrive. Now here is where the condor's own biology becomes the trap. This bird evolved to eat rotting meat, carcasses days or weeks old, crawling with bacteria that would kill most animals. To handle that, the condor developed one of the most powerful digestive systems in the bird world. Its stomach acid is ferociously strong, strong enough to dissolve bone, strong enough to neutralize deadly pathogens like botulism and anthrax. That acid is the condor's superpower. It is also the thing that kills it, because when those microscopic lead fragments hit that acid, they dissolve instantly, not slowly, not partially. They convert into a form the body absorbs straight through the gut wall and into the bloodstream. And once lead is in the blood, the damage is systematic and devastating. Lead mimics calcium at the cellular level. It binds to the same receptors. It shuts down the enzymes the body uses to build the molecules that carry oxygen. The bird becomes anemic. Its nervous system starts to fail. And then the cruelest part of the whole chain kicks in. The muscles that line the bird's crop, a pouch in the throat where it stores up to 3 pounds of food, go completely paralyzed. The crop freezes, the food inside it can't move down into the stomach. The bird can't cough it up either, so it sits there, rotting inside the bird's own body, while the condor slowly starves to death with a throat full of meat it cannot digest. It is the signature way lead kills condors, and it is as mechanically cruel as anything in nature. If this were happening to a species that breeds fast, pigeons, sparrows, anything with large clutches and short generations, the population could absorb the losses. The condor cannot. This bird takes 6 to 8 years to reach breeding age. It lays one egg every 1 to 2 years. One. And then it spends 6 months raising that single chick, sometimes longer. Even a small number of adult deaths per year outpaces the birth rate. Between 1982 and 1986, the annual death rate among the remaining wild birds hit nearly 24%. At that rate, with a population of 22, the species had years left, maybe less. The system was trapped, the food was poisoned, the bird's own biology made the poison more lethal, and the species reproduced too slowly to absorb the losses. Every variable pointed in one direction. Before the radical intervention that eventually pulled the condor back, the prevailing strategy was simple: protect the habitat and leave the birds alone. Throughout the 1960s and 1970s, conservation groups and government agencies poured enormous political energy into establishing sanctuaries. Thousands of acres in the Los Padres National Forest, the Cespe Condor Sanctuary, vast tracts of rugged, beautiful, legally protected wilderness. It didn't work, not even a little. The problem was a fundamental misdiagnosis. The assumption was that the condor was declining because its habitat was shrinking, because people were getting too close. So the prescription was space and solitude, but a condor can fly 150 miles in a day. A line on a map means nothing to a bird that crosses it before lunch. A condor could roost on a protected cliff, soar out over private ranch land, eat a lead-laced gut pile, fly back to the sanctuary, and die there. The sanctuary protected the bird from everything except the thing that was actually killing it. From roughly 50 birds in the 1970s, the population fell to 22 by 1982. The sanctuaries were intact. The birds were gone. And when a new generation of biologists, led by a field researcher named Noel Snyder, proposed the only remaining option: capture every last bird and breed them in captivity, the conservation establishment erupted. Snyder had spent years in the field with these birds, watching them die one by one, and he'd arrived at a conclusion that horrified his peers. The hands-off approach was not saving the condor. It was supervising its extinction. The only chance was to pull every remaining bird out of the sky and try to breed them in zoos. The opposition was fierce. The argument, made loudly and publicly by figures including David Brower of the Sierra Club, was that capturing the last condors would break something that couldn't be repaired. That a condor in a cage was not a condor. That a species reduced to zoo specimens had already lost everything worth saving. Better, some argued, or to let it go extinct with dignity than to reduce it to a managed curiosity. This was not a fringe position. It was the mainstream conservation view, and it was wrong. The capture program began in 1985. The last wild condor, a male later given the stud book number AC9, was taken from the sky on April 19, 1987. The species was now entirely in human hands. What followed was an engineering problem with no instruction manual. The first challenge was basic biology. Nobody had ever bred California condors in captivity at scale. The birds are long-lived, potentially 60 or 70 years, and they bond as pairs over years, not weeks. Getting them to breed required creating environments that approximated wild conditions closely enough to trigger natural behavior in birds that had never seen wild conditions and never would. The second challenge was the egg itself. A condor pair in the wild lays one egg per season. If that egg fails, the pair may or may not try again. But biologists discovered something useful. If you remove the egg shortly after it's laid, the female will usually produce a replacement, sometimes two. This technique, called double clutching, effectively doubled the breeding output of each pair. Triple clutching, used in some cases, pushed it further. The removed eggs went into incubators, and later the hatched chicks needed to be raised without imprinting on humans. This led to the puppets. Because condors learn by watching adults, chicks raised without parent birds would have no model for how to be a condor. They would emerge from the program behaviorally blank, capable of flying, but with no sense of how to find food, interact with other condors, or navigate their social world. So biologists built hand puppets shaped and colored like adult condor heads. Handlers fed chicks exclusively through the puppets, keeping human faces and voices entirely out of the chick's experience. The goal was to make the bird's earliest memories, food, warmth, safety, associated with condor shapes, not human ones. For social learning, biologists used surrogate parents, older, behaviorally competent condors who had grown up with proper role models. Chicks were transferred to surrogate pairs who raised them as their own. The surrogate learned from watching real adults. The chick learned from watching the surrogate, a chain of behavioral transmission rebuilt link by link. The third challenge was genetics. 27 birds is an almost impossibly narrow genetic base for a species recovery. Inbreeding was not a distant risk, it was an immediate one. The solution was a software system that tracked every bird's lineage and modeled the genetic consequences of every possible pairing. The goal was not just to produce chicks, it was to produce chicks that maximize the genetic diversity still present in the population, slowing the inevitable narrowing. And then there's the fourth system, the one that makes the whole thing feel less like conservation and more like running an open-air intensive care unit. Because the wild landscape is still poisoned, lead ammunition is still out there. Yet California banned it statewide in 2013, and voluntary non-lead programs in Arizona and Utah have hit 80% compliance on key feeding grounds. But compliance is not elimination. Condors still find lead. They still eat it. And their stomach acid still dissolves it just as efficiently as it ever did. So every condor released into the wild carries a GPS transmitter and a numbered wing tag. Field teams track every bird every day. If a transmitter stops moving, someone goes looking. Twice a year, the entire free-flying population is trapped, every bird. Biologists lure them into large netted pens, draw blood, and test for lead levels. If a bird comes back hot, blood lead above the danger threshold, it gets pulled from the wild and rushed to a veterinary facility. There, a team administers chelation therapy, a chemical treatment that binds to the lead molecules in the bloodstream so the bird can flush them out through its kidneys. In severe cases, with crop already frozen, bird already starving, surgeons install a feeding tube that bypasses the paralysis entirely, keeping the animal alive while the chelation slowly restores muscle function. This is not a temporary measure. This is the permanent operating condition. As long as lead exists on the landscape, this medical system runs. Every bird, twice a year, indefinitely. Remove any one of these four systems and the whole thing fails. Growth too slow, birds too tame, genes too narrow, lead too fast. Each layer covers a gap the others cannot. The condor's survival depends on all of them running simultaneously across multiple states and 2 countries. For the first 5 years, there was nothing to show for any of it. From 1987 to 1992, 0 condors flew anywhere on the continent. The entire species sat in enclosures while biologists refined incubation protocols, tested rearing techniques, and practiced release logistics using Andean condors as stand-ins. The first captive-bred California condors hit the wild in 1992, released into the mountains north of Los Angeles. And immediately, things went wrong. Puppet-reared birds with no adult role models collided with power lines. They drank antifreeze from puddles in parking lots. They scavenged human garbage. Several had to be recaptured, put through aversion training, including sessions with mildly electrified mock power poles to teach them that wires mean pain, and re-released. It was ugly, it was slow. Every death felt like a failure of the entire system, but the system kept running. The incubators kept producing eggs, the surrogates kept raising chicks, the genetic software kept selecting pairs, and one by one, the birds began to figure out how to be wild. In 2004, field biologists tracking a pair in the mountains of Southern California confirmed something that hadn't happened in decades. A chick had hatched and fledged entirely in the wild. No incubator, no puppet, no surrogate. 2 condors had mated, nested, and raised a chick on their own, on a cliff face, in open sky. 4 years later, in 2008, a routine census produced a number that rearranged the entire trajectory of the program. For the first time since the crisis began, the number of condors flying free in the wild exceeded the number held in captivity. The wild population was no longer a tiny experimental offshoot of a captive colony. It was becoming the main population. And then, in 2019, in a cave tucked into the sheer sandstone walls of Zion National Park in Utah, monitors confirmed the hatching of the 1,000th condor chick since the breeding program began. The bird wore a black wing tag reading 1K. It survived, it fledged, it flew. As of December 2025, 607 California condors exist on Earth. 392 of them are flying free across 4 distinct wild populations. 216 in Central and Southern California, 98 at the Grand Canyon, spanning Arizona and Utah, 53 in Baja California, Mexico, and 25 in the Pacific Northwest, the first condors to inhabit that region in over a century. 215 birds remain in captive breeding facilities, still producing the next generation. In 2024 alone, the Los Angeles Zoo hatched 17 chicks, a single-year record, using the triple brooding surrogate method that didn't exist 7 years earlier. But honesty demands the full picture. Since reintroduction began in 1992, 161 free-flying condors have died from lead poisoning. Lead accounts for 50% of all wild condor deaths where the cause is known. In 2025 alone, 9 of 22 recorded wild deaths were lead. Population models are unambiguous. Without the biannual trapping and chelation, the wild population would immediately begin declining again. The system is keeping the species alive the way a dialysis machine keeps a patient alive. The underlying condition has not been cured. The whole system costs roughly $5 million a year. That covers the breeding facilities, the genetic software, the GPS tracking, the biannual trapping, the blood testing, the chelation therapy, the surgical interventions, the field teams across 4 states, and Mexico. $5 million. For context, building a single mile of basic highway in California runs about the same. The entire annual cost of preventing the extinction of a species that has existed since the age of mammoths is equivalent to repaving a short stretch of suburban road. And the system's reach has extended into places nobody originally designed it to go. The forensic toxicology work that proved condors were being poisoned by ammunition, not background lead from paint or industrial residue, used chemical fingerprinting so precise it could match the lead in a condor's blood to the exact signature of bullet fragments in the carcass it ate, with less than 0.25% difference. That evidence forced California's statewide ban on lead ammunition. And the ban didn't just protect condors. Follow-up studies found measurable drops in blood lead levels in golden eagles and turkey vultures across the same region. A law written for one species accidentally built a shield over an entire class of scavengers. When a devastating strain of bird flu swept through the Arizona flock in 2023, killing 21 condors in weeks, the response proved how adaptable the system had become. The recovery team pivoted within months, tested a poultry vaccine on black vultures as a trial species, then deployed it across the wild condor population. By late 2024, 207 condors had been fully vaccinated, 134 of them free-flying wild birds trapped specifically for the shot. It was the first emergency vaccination of an endangered wild bird species in history. And in 2022, the Yurok tribe released the first condors into their ancestral territory in Northern California, ending a 100-year absence. The Yurok call the condor prego niche, and its presence is woven into their origin stories and their ceremonies for renewing the world. The birds received traditional Yurok names, Poiwesan, meaning the one who goes ahead, and Nesquechoku, meaning he returns. In 2024, a female from that first released group laid an egg, the first condor nesting event in Yurok territory in over a century. For a people whose spiritual framework centers on the balance between humans, wildlife, and the earth, this was not a data point. It was the return of something that had been missing for generations. The California Condor is not a story about nature healing itself. It is a story about what happens when you accept that nature cannot heal itself. Not this time, not under these conditions. And you build a machine to do the job instead. 607 birds where there were once 22. 4 wild populations where there were none. But the machine cannot be turned off. As long as lead persists on the landscape, the trapping continues, the blood draws continue, the chelation continues. The condor flies free, but it flies on a tether. And the question that hangs over all of it is whether that tether is a bridge to something self-sustaining, or whether this is simply what survival looks like now. Not recovery, but permanent, deliberate, mechanical life support. Either way, the system works. Not because it is elegant, not because it is cheap, because it addresses every failure point simultaneously, instead of hoping that fixing one will take care of the rest. That is not sentimentality, that is engineering. If that kind of story interests you, subscribe to the channel.